Hello students, good morning. Shreya, you can start.
Yes, hi all. I am Shreya from the Baha Alumni Committee. Good afternoon, everyone. I welcome you to this Ansys training session designed exclusively for Baha India teams today on Sunday, 7 December 2025. We are focusing on use of powerful simulation tools to optimize your vehicle's design, performance, and safety. So, firstly, we will start with Ansys Granta and basic training. We will begin with Ms. Shanti Prabha. She is an application engineer at Ansys India, over 7 years of the experience in structural and thermal analysis and material data management. She will cover the introduction and training on Ansys Granta. So I encourage you all participate to please participate in the Q&A session at the end of this workshop. So let's get started with today's session. Over to you, Ms. Shanti Prabha.
Hi everyone. Am I audible?
Actually, ma'am,
Yes,
your
ma'am.
voice is not clear.
Hello. Am I audible to everyone? Is it better?
Yes, now it's audible. Yes, it's better.
Okay. So in this session, let me quickly give you an outline and then start with our topics. Just a second. Let me share my screen. Let me know if it is visible. I One second. Yes. Hi. Can you all see my screen?
Yes,
Yes.
ma'am, it's visible.
Okay. So this is the outline of today's presentation, and I came to know that you are working on SAE Baha and you wish to focus on you wish to do some work on sustainability and eco assessment. So the outline will be like this. What is Granta Selector? Because that is the tool in which you are doing eco assessment. Then how to do eco assessment, followed by a demo and an example. If you have Granta Selector, you can try it out on your end. Moving on. Why this Granta Selector is there? When you do a product design, I hope you know that you optimize the design, geometry, loads, and so on. And you also select the right material, which equally affects the technical performance and cost of the final product. Therefore, by using the material and design correctly, you get the optimal product. So, what this Granta selector does, it is a standalone desktop application, and you see some tools like this. I won't go into about it, but just to help you understand what it is. First, there is an encyclopedia of materials data. Then there are tools to visualize and filter the data so that you can make the right material selection. That is the aim of this tool. In order to do that, there are many features which it has. Okay, and one of the features is Given the material, what is the sustainability? What is the carbon footprint or embodied energy? That is called eco audit. Uh, yeah, and you have integrations. So with this tool, if you have doubts with what material to use, or if I have a material, how to substitute it with a more sustainable material, confidence in the choice, and therefore um, it increases the speed for your uh, product design and R&D work you might be doing. So yes, there is a systematic material selection methodology. If you have studied about Professor Ashby, you might know that some more 30 years ago he was the person who laid out this procedure in a book, and he was also uh, mostly he founded this Granta organization, which was later acquired by Ansys. Select any material, identify the function, constraint, and objective, and then apply some filters on it. Then select the materials which you can later use it for CAD and simulation. And there is data, no need to focus too much into this. Some data comes along with Ansys and some are add-on databases. So one more thing you can do inside this tool, there are many inside Granta Selector, there are many tools to help you select materials. These are for visualization, comparing, and so on. One of the tools is Eco Audit. Okay, on and that will help you do sustainability analysis. We will look more into that today. With that, let me share a different PPT. So we will go in more depth on eco audit because that will be the focus. Meanwhile, let me open Granta selector in the backend. Now, yes. So why do we need to do eco audit? Uh, okay. Do you know the life cycle of a material? It is first produced, mining or whatever, then manufactured, then the component is used by a user, and uh, that is, it goes to its end of life. It is either put in a landfill or it is combusted, whatever. Many of these, if you see, they are not circular. Sometimes, if we melt them and remake them, then it is circular. So, uh, is so at each stage of the life cycle, we wish to estimate the environmental impact. That is the aim of this tool. And yes, you can also explore how to reduce carbon footprint, different ways to do it. So first, like I said, in the material production, manufacture, any transport, usage, and end of life, each stage consume different amounts of energy and also leads to carbon footprint. These are just some examples. If you use a virgin material, you use up a lot of energy, but if you use uh, a recycled material, you end up using lesser amount of energy. So there are some examples like that. You can think about each stage. How do we do it inside eQuadit? It looks like this. Need not focus too much here because I will anyway show it in a demo. There will be something called a bill of materials. You will have a part list. You will have materials, okay, and you will have their mass, and you will see what processing is happening on them and what happens to them at the end of life, and any joining you're doing or transportation you're doing on top of that, right? And the tool looks something like this. Input, yeah, like I said, you can input a lot of things. Mainly, you input the material manufacturer and end of life. And finally, what you get, the result looks something like this: plots of embodied energy at different stages of the life cycle of this product. So, this is an example. So, we'll see two examples. One is this smoothie bottle, another is something more related to your use case, steering wheel. Okay. So I just took this because it is a very simple thing and it has just three parts in it, and it has a very simple assembly, just to make you understand the concept. Like, what are the three parts? Cap, bottle, and the liquid drink inside it. And the bottle is loaded like a panel in bending. So this is a panel in bending. What are the constraints? It should be okay with food, yeah, weak acids, and so on. This is if you're doing a material selection for that. But assume that you have arrived at this material, PET for the bottle cap, and polypropylene for the bottle body and drinks. Next, we'll see uh, how to do this in Granta selector. Let me check if it has opened. When you open Granta selector, it will look something like this. The home page, it'll have a brief overview of what databases you have. And if you want to see here, you can see the tree location has changed. So there are, and each of these is a database. And you can see a brief write-up about what is inside this database, like that. And on the left side, this is called tree. And yeah, this is how it looks when you open it. Moving on, uh, this eco-audit is what you are most interested in. So let me quickly explain that. So give it a name. Uh, Give it a name. Select the material. In that case, it was PVC. Right. Mass, it was around a very small mass. And blow molding, sorry, it was in injection molding in this case. Then you can leave the secondary process or just put some machining. Then you removed, let's say, started with 100 grams, you removed 10 grams from it. So percentage removed while machining. End of life, assume it goes to landfill. Joining and finishing, I guess you can use that if you're using. Maybe it is transported by truck over large distances. Select your mode of transport over some 500 kilometers. usage. So if it is using electricity to be stored in a refrigerator, um, you can just put the value and you can enter the values. And then once you click summary chart, you will see, okay, maybe I entered such a big value. Right. You can see the comparison of different stages of the life cycle, or even I'm just trying to show you the comparison here. Okay, so material is there, and what are you seeing here? Embodied energy. So in kilojoules per kg of the product. Carbon footprint, you'll see kilograms per kg of the product. Okay, and then you can close it. Detailed report. Sorry. So, how does it look? What we saw, embodied energy versus climate change charts over different stages of life cycle. And right now, you have the first page, right? And detailed breakdown over different stages of life cycle and different steps which happened, detailed breakdown and what happened. See, in for disposal, just to put it in a landfill also, it is consuming a small amount of energy, and that will change if you use a if you send it to recycle or whatever. And end of life potential is 0. If you recycle it, you will get end of life potential, but what will it be? It will actually be in minus, so that will return back what you consume during production. We'll see that in more detail. So what I will do, obviously this one part is not enough. You can see this. Yeah. Okay. In Okay. During usage, climate. Okay, one page is there for embodied energy, another page for climate footprint. Go back to product definition, open a part. Just a second. I'll open some parts and show you. Okay. Here you can all see my screen, right?
Yes,
Yeah?
ma'am.
Yes,
It's
yes,
visible.
ma'am.
Okay. How I have done this, open it, and there are some PRD files. I will also show you how to get that. Click on them and open them, and you open this part. And if you wish to save this as a PRD file, you click on save and give it a name, and it will save. Now, okay. So here this is an opened part. It's already made. What are the changes from what I showed you? Here they are manufacturing 10,000 bottles, not a single bottle, and it is made with PET plastic. It's a PET bottle, and polypropylene is the bottle, and masses, small masses, and they are all going to landfill. If you wish to compare it with a different part, yeah, sorry, not a new part. Compare it with a saved product, the second drinks bottle. Okay, this blank product I'll close. So here, what is the difference? Yeah, so from here, the PET which they are using is recycled 100%. And drinks bottle 1 and 2, what do you see? Mostly during the production phase, you see a drop. And compare it with a saved product. So here, yeah, we do not have a lot of time, I guess, to do a material selection. So what I'll do, or maybe I can just take uh, 5 minutes for this. This doesn't show everything, but the main features it will show. So what we saw here, suppose we want to change this material. Uh, okay, you can reach out to me if you want to do this part of the process, or maybe you do not want to go in here at all. To do material selection. So what we saw here, so we'll apply all these criteria. Okay, and we'll see how we can do it. So to apply the criteria, there are some features in Granta Selector. Search and visualize and filter. So if you have to select a subset from one database, so you can select a subset or just select polymers because okay, we'll come to that. In fact, you can select all bulk materials here. What we'll do, compare it with our original material, PET bottle. Take that, mark it as reference. And why we are marking it as reference, we'll search for other materials and compare it with that reference. And you can see it is marked as reference. Then what do we do? We can do a chart index. So there are thousands of materials. Among the thousands of materials, you wish to compare based on two properties, one along X and one along Y. It's okay. I'll be there to answer doubts if you have in this section. But just select two properties. You can select a single property or build a performance index. Performance index is nothing but a combination of two or more properties. That is okay. So what should this drinks bottle do? It should not be allowing oxygen to pass through, because if oxygen passes through, the drink will get spoiled. So it should be a barrier. And what else? You need to have less permeability to oxygen, but you need the minimum amount of stiffness. That is the only thing you need to remember. And what are these? These are different loading cases. So the most simple loading case is like a beam and bending. Okay, and okay. So you want to have less permeability per unit stiffness. Just remember that, and you'll have a combination of two or more properties. And in x-axis, do a similar index here. Okay, select panel and bending, stiffness, but here optimize embodied energy. So this is the structural loading you are taking here. Okay. So mainly what you see is y-axis permeability and x-axis embodied energy. Yes. And what do you want to select? Something in the lower side and left hand side. Something in this area. And where is your reference material? This is your reference material. And what are the different colors? They are different families of materials, elastomers and plastics. Okay. Then what else you can do? You can say it has to be compatible with blow molding. So go to the tree stage, select shaping, molding, and blow molding. Insert that. So what you're saying is compatibility of material with processes. You have applied a selection stage and one filter stage. So what I have done, how to compare, filter, and how to apply three processes like compatible processes. Then here, just put durability with weak acids. There are. So the reference material is acceptable. You want something acceptable or excellent when it is in contact with uh, weak acid like orange juice, food contact. Yes, because this is a drinks bottle. Apply that and quickly go back to stage one. You'll see a lot of them are grayed out. Hide them. Go on the ones which are not gray and find some options in the lower left side. So, what do you see here? You got two options. If you're just focused on sustainability, select the uh, leftmost one, minimum embodied energy, and quickly go to a comparison table. What it shows you is this has a very low embodied energy, around half compared to reference, and of course, it is safe for food contact. And also, this is uh, renewable content, means it's a biodegradable polymer, unlike PET. Okay, and you can also see detailed properties here and compare each one. Yeah, you can see it's a biodegradable polymer, unlike other polymers. Anyway, going back to this drinks bottle, what I'll do, compare it with another product which is made with PLA. And here you can see PLA also leads to reduction in uh, sorry, what? No, this is the case with, okay, this is the case of PET, but mass is reduced. Okay, so how many drinks bottle? One, two, okay. We'll just name it and compare with saved product. What we'll do, yeah, we'll change this to PLA, GAPLA. It is called polylactide general purpose. We can look at mass reduction later, but we'll see the original mass itself. Yes. So, what are these? Name them. So, this is So, regarding the two or three questions we started with in the beginning, right? What are the questions? How to reduce your carbon footprint? So, how to reduce? One is by using recycled content. Another is by reducing mass. Another is by you kept the same design, mass, and everything. You're using uh, uh, more uh, environment friendly polymer, environment friendly material. So these are the three ways you do it. Okay, let me just keep the name. Yeah, okay, PLA. So you can see recycled less mass with PLA and what happens each time. And you can see embodied energy and carbon footprint. And you can see the detailed reports also. Okay, this is however for one product. So once again, to recap, what is this? This is like a quick bomb. Quantity, component name, followed by material, manufacturing process, mass, and usage, transport. Okay, you enter them and you do a quick sustainability analysis. Moving on, what I thought will be useful, are any of you trying right now? Are any of you trying this with the software?
All teams can like put their questions in chat box or reply on the questions on the chat box.
Yeah. So I have created a case study in case anybody is trying. So here, this is for a steering wheel. I just quickly put it together. I have only included three parts, small assembly to keep it simple. So steering wheel, tie rod and link arms. How can you do that? You can create a new product. So this I did a quick search in internet. Of course, so many other alternate materials can be used. So it it can be some kind of cast aluminum. That is something I found in the internet. Aluminum, a lot of it is recycled. In fact, you can use the typical percentage. This comes from the backend Granta databases. Or you can say reused part, or you can say yes, or you can exactly type the percentage here. Then, what was the other two cases? Yeah, sorry. Yes, steel tie rod, aluminum link arms. Okay, 1.2 kg, 2 kg. You can also change the quantity. I'm just showing it as an example. Everything may not be accurate. You have to do the design first, then optimize the mass and bring it here. I'm just selecting the first material here and so you can change, play with the recycled percentages. You can something steering wheel. You can yeah. You need to give the process. Already you have some existing processes. Okay, if you have uh, found a new process, mostly what is compatible with this material will come in the drop down. If you see in the previous example, we got things like uh, polymer blow molding, but here we are getting metal casting, extrusion, and so on. You can do something, machining, okay, and okay. To see what happens if you recycle at the end of life, because see these options will also change. 100% recycling usually you can do for metals, but for polymers you cannot do 100% recycling. Yeah. So put the percentages accordingly in a realistic way, and then so this example, why did I take to show you what happens with the end of life? Yeah. Now, mm, right, sorry. So what I'll do, okay, I will close all the previous examples to make it more simple. Okay, so you saw the breakdown in different stages of life cycle, and what you see here at the end of life, this is a minus. So that means what you consume during production, you're kind of giving it back. So that is what recycle does. Okay, so that see these are different. Recycle at the end of life, but when beginning, you're using recycled content. So when yeah, both are different. Keep that in mind. Okay. Now, the rest of this time, I'm not sure. I thought you were following with the tool or whatever. But yeah, if you have questions, you can bring it up.
Teams, please put your questions in the chat box. Shreya, can you read the questions?
Yeah, I can see some questions.
Yeah, the first question is, should we enter the mass of the final finished component or the mass of the part before secondary processing?
Yes. Yeah, that is a good question. So the mass you take is before secondary processing. Okay.
Yes. Okay, the
Now,
next question is, ma'am, can you explain to us about the use phase?
use phase. Yes. Use phase, what you see here, and there are different ways you can use a product. So product life, first of all, 1, 5, 10 years, where it is used, it matters because, as you know, the sources of, if you take electricity, sources of electricity and cost of electricity, both are totally different. And if it uses the following energy, mostly it might use electrical from a socket, okay? Or if it's an engine, it's burning fossil fuel. And power rating, so how much power it consumes and for how long it consumes together gives you some energy. This is power, and time gives you energy. So energy it consumes during its life cycle. Okay, and if it is carried in a vehicle, the type of vehicle affects how much um, energy it consumes. It can consume energy in a car, gasoline, or in an electric vehicle from your mains electric supply. Okay, then uh, if you have more doubts about this, what you can do, everywhere you see there are small help buttons. You can go here, for example, and it will take you to a web link. Okay, meanwhile, what other questions are there?
Ma'am, the next question is, if the primary process is not mentioned in the list, what we are supposed to do and how much does this affect the report exactly?
Yes. So first, are the previous questions clear?
Yeah. Uh, Students, the use case question is covered now. Yes.
This question was what I sorry, what was this question?
If the
Yeah,
primary
processing.
process, oh, this.
Yes. Yeah, so add custom process. Yes, Suhas, we can take that question next. You can see some raised hand. Uh, so, if it is not covered, you have to add a custom process. In that case, you will have to know the you have to energy it consumes. You will need to know, and so the value you gave, it is using that in the back end to calculate because it's your own process. You should know. Okay. Does that help?
Yes, yes, ma'am. I guess teams understand that answer. Ma'am, the next question is, what is the transport that we need to consider? Is it the buggy transportation from our place to the event or the component transportation for the sender to us? Actually,
Yeah, good question. I don't know.
this we have to, if you are doing this analysis on the separate component, so you have to consider the component transportation. If you are doing for the buggy, whole buggy, so you have to consider the buggy. Yes, Pranita. I guess you
Yes.
will got this.
For a however, yeah, for each component you will have to consider transportation differently. Or what you can do is, if each component, maybe five components are traveling 100 kilometer over a truck, you can put a truck and just put 500-kilometer distance. Am I making sense?
Yes, yes, ma'am. Yes. The
Okay.
next question is, how should we calculate the process
We
energy
had
if
a
we are
raised
selecting
hand,
the...
Suhas or someone.
Actually, ma'am, like I'm like reading the
Yes,
questions
sir.
from the chat
Yeah, yeah.
box.
Yeah, tell me.
They are not
Yeah.
allowed to
Okay.
speak. Yes.
Okay.
So how should we calculate the process energy if we are selecting the customized process for the primary and secondary process?
Process energy. So processes are given whichever is compatible with the material. Okay. If you a custom process, first of all, means you have discovered your own process. So when you discover that, you should know the uh, embodied energy and carbon footprint of that process. However, what happens in the back end of selector is it uses something called eco-invent database. That is a database from the eco-invent organization, and that is available as one of the databases. Where is that? If some database is not available here, change it to metals plus. All of your selection projects will be erased. uh yeah, change that. This is just to give you an idea of what happens in the backend. Okay, fine. Meanwhile, let me show you the help. So let me talk you through that. My computer is frozen. So there is a database called EcoInvent, and that EcoInvent gives you carbon footprint, sustainability of so many different processes and materials. That is what is used in the back end of Granta Selector. That database is available in Granta Selector. You can go there, take the carbon footprint and embodied energy of that process if it is available. But then again, if it is your custom process, it will not be exactly same. Where is that? Eco-invent key indicators. So here, there is a process tree. Go in processes, whatever is compatible with metals. So many processes are there. How does a typical database look like? So it looks something like this. It also gives you how much water it consumes, how much abiotic oxygen depletion is happening. Okay, Europe and rest of the world. It's just some classification they are giving. But end of the day, you will get a clear idea of embodied energy and climate change. However, only if uh, so what you see here is what is 100% compatible with that material. So if you have made a custom process, you can take help from the EcoInvent database, but not don't exactly copy it. Yes. Or you have to justify, okay, what you're doing. Yeah. Does that answer the question? So does that answer the question? Okay. Do you
Yes.
have any other questions?
So the next question is, ma'am, could you please explain the percent recover either from material processing or from end of life?
Percentage recovered, percentage of what?
Percentage recovered either from material processing or from end of life.
Okay. There is no such thing as percentage recovered from material processing. Okay. Material processing is, how can I put this? Manufacturing, there is nothing, it consumes energy, it doesn't give you back energy. So if you see some basic report, manufacturing consumes energy. That's it. End of life. Yes. So what this means, you have a piece of aluminum, you can throw it away permanently, and when the next time you want a piece of aluminum, you can start to mine it again, search the ore and purify it, so extraction, and you can spend energy on that again. Or the existing aluminum you can um, recycle. You will, so actually, if you use an existing piece of aluminum, the entire 20 you have to give back, and there is no cost of uh, pro cost of processing new aluminum, right? Uh, yeah, so sorry. This processing you might have meant. So there will be zero cost of processing if you take a new piece of aluminum, uh, if you take an existing piece of aluminum. But uh, for that existing piece of aluminum, maybe you have to do some surface finish, remove some oxidative layer, and mainly, uh, and of course, it will be in some existing shape. You will have to melt it. So till that part, you are spending energy. So it is not exactly 20, or if you see in energy charts, it is not exactly 320. So that is for purification, you can say, but essentially it is in minus, you are giving it back. So does that make sense? So what it means is, comparing, you're just throwing it away and nobody is using it again. Everybody who wants to use it again is mining it or processing it again. But instead, you're, instead of throwing it, you are uh, recycling that part. So some benefit has to be there, right? So you are getting energy, not spending, by recycling. Am I making sense?
Ah,
Okay.
yes, ma'am. Yes.
Any other
The next,
questions are there?
yes, is the next question is, should reports to be done for the buggy as a whole or only for the components or both? Lawrence, if you read the guidelines carefully, so we mention only for the 10 components. So that components you have to include it in your report only. I hope this is clear to you. Ma'am, the next question is how can we evaluate vehicle range? Is there any formula for it, or do we calculate it from the energy consumption? So can we
Vehicle?
can we get vehicle range from this Ansys Granta or not?
What is vehicle range?
If vehicle is electric vehicle, so can we get the range from this Ansys Granta? No, I
Sorry, what
guess.
is the range?
How much vehicle can travel in one charge, like that only the students are asking.
Uh, that
I
will
guess
depend
no.
on your battery, right?
Yes, yes, yes. Shruti, in the guidelines we mention about the vehicle range that we will be evaluating on the phase three on the dynamic event. So that depends on the your energy consumption also. So that guidelines we will separately release after this presentation of phase two.
Okay. So ideally for components, do it from the manufacturer, not just
Yes.
from where you are assembling it. If you are using some trusses, do it from production of aluminum and
I hope.
include any joining finishing process you're doing, and write the values up to end of life. I know you may not actually go and recycle, but as an exercise, try to find out what is happening around you. Many times, steering wheel, if it is aluminum, it is coated, sorry, not coated, it is covered with PU foam, or it is covered with even natural leather. So, for the even for those materials, try to understand what is happening at their end of life around you. Look around you, try to put it. Yeah.
Ma'am, there is one question. Should it be done in one report or we have to generate different report to make it into one report? So like the a student is asking regarding the eco audit primary, then material selection and the final eco audit report. So we can generate it separately.
Okay, wait.
Uh,
Material selection report, that is a good question. Keep that separate. Eco audit, keep that separate. See, material selection, that is a good question. It comes from structural criteria also you'll have to take into account. Material performance, durability, whatever. You can include sustainability also in that, but that is a different thing. And for that, go with chart report. This will give you a, this is nothing to do with eco audit. Will give you a report of material selection exercise which you have done. Okay. I'm not sure if the stages are still there. I changed the database and all. But whatever filters you have applied, here stage by stage based on your filters, it will give you a report. Okay. Uh, do this report separately. Eco audit, you can do everything in one report, but you can use different sections under a report or whatever. Make it legible. Make it clear. Um, Make your carbon footprint and embodied energy all that clear. So even later, if you work in this topic in industries, you have to give the genuine idea of what is happening. So this is called a selection report. This report will show you what different filters you apply during selection, stage by stage summary, and different pages for individual stages. Okay, keep this separate. And for sorry, eco audit reports, keep these eco audit reports separate. Keep these reports separate. Am I making
uh,
sense?
yes, ma'am. Sure. Ma'am, the next question is, ma'am, when substituting a less dense material in eco audit, should we calculate the weight reduction in part mass manually, or is there any feature to calculate it automatically?
Yes, less dense material. That is a good question. So, uh, less dense material, you can do a material selection exercise. Okay. Uh, so if you do a material selection, what you will get is the whole thing is stuck. Okay, fine. For now, I'll close this material selection. So coming back, let me show in using PPT. If you use a less dense material, what happens is you saw this, right? Panel
Yes,
and
ma'am.
bending. Okay, so you will have mass per unit stiffness. What did we see in our example? We saw embodied energy per unit stiffness. Instead of that, you will have mass per unit stiffness. So, using selector, so material selection is like the first stage of your process. Before you start the design, first stage, you will have something like mass per unit stiffness. And if you change a material, you will get how much reduction in mass per unit stiffness. Then you will get that maybe 10% reduction or something, that you will get an estimate. If you are okay with that estimate, use it. But in this presentation I did not include the design. When you change a material, usually you go into the design, do any topology optimization. Then if you are going into depth, usually you might do FEA also. Then after that, if you got the exact number, this is a broad percentage. If you got the exact reduction in mass, it will be same, but after FEA it will be more accurate. If you got the 10% reduction and that final value you have to put it in eco audit. Eco audit is the last stage of your design. So if you change the material in eco audit, usually you have to, like I showed you, I went back and did a material selection. Then you might have to do topology optimization, design optimization. That mass will again go into eco audit. So that is the circle. So you might broadly take it as material selection, design optimization, eco assessment.
Okay.
Okay.
Yes, yes, ma'am. The next question is, what should we do about recycle content when we are using reuse parts? The transport and use must be included in the report or not?
Recycled content. I didn't understand how is that related to transport and all.
Like actually, ma'am, they are saying if they are using last year components that they are reusing, so like the transport and
Okay.
all the things they have to mention or not.
One second, let me think. If you are using last year's content, okay, if you are treating this as an individual project, yes, if you are treating this as an individual project, for you, the recycled percentage will be 100%. So, for you, recycled content will be 100 percentage. Okay, and end of life for last year will be 100% for that part. For this year you do not know, go and find out. Okay, but see, just because every time if you keep saying we are using last year's content, it is not going to make sense, and you have to answer at some point from manufacturer how this component, where you are accounting for that number, maybe 1 year ago or whatever. One time you have to account for that number from manufacturing, what is the energy it took, processing, manufacturing, how it came into your college. Then at the end, for this year, definitely you have to include. Just don't say we'll keep it for next year. For every time you cannot do that. At some time you have to include where it will go out. Find out if, for example, polymers is very interesting. Is somebody dumping it at a landfill near your place or whatever? At some point, yes, I would like to see that, because every time if you keep saying, yeah, we took last year's material and we are going to save it for next year, everything will be 100%, but your college is not a closed system. In fact, maybe at the country level you can take it as a closed system, but even that is not full. So you have to think of the bigger system, and at some place you have to give the numbers, right? Because every time if you say we took it from last year and we're keeping it for next year, then everything is 100%, right? But
Yes.
yeah, at some point you would have paid the cost to process and manufacture it, right? To produce and manufacture. Sorry, not process and manufacture, production and manufacture. I kept saying process all this time. At some time, you would have paid the cost to produce it and manufacture it. Likewise, at some time, you will pay the cost to send it to landfill or recycle it.
Okay. There is one last question, ma'am. So when
Okay.
choosing a alternate material, what if its CO2 footprint is much lower than the current material, but there is a trade-off which respect to its mass, then should we select the particular alternate material or use the recycled version?
Ah, so there are three things I'm hearing here. One is in the new material there is a reduction in carbon footprint, but there is some other trade-off, maybe mass or cost. Okay. Then what was the third point? Recycled content. So this is a totally different point. Keep that separately. Usually, when selecting a material, uh, use so there are three things. um, Technical performance, strength, stiffness, whatever. Then mass, lightweighting, or cost. Then sustainability. Among these three, yes, you have to apply your brain and find some optimum which works for you, but you should be able to justify why. Okay. And regarding recycled content, that's a totally different topic. What did we see using the examples? At any time, compared to using a virgin material, if recycled material is available, that is always the best choice. I'm giving you the answer right away without you having to work on it. Okay. If it is available, it is always a better choice. And when designing, you do not have to radically change your design also.
Uh, yes, I guess we covered all the questions from the students.
Okay.
If you have any more questions regarding sustainability, like you can connect with your alumni coordinator and we will get back to you with the answers. Okay. Okay, ma'am. Like
Uh,
we covered all the questions. Shreya.
yes, please. You got my email?
Ah, yes, yes, ma'am. Yes.
Yes, feel free to reach out to me.
Yes, yes. Shreya, can we wrap up now?
Yes.
Yes.
Thank you, ma'am, for this useful session, and thank you all for joining this session. Conclude the
Yeah,
meet now.
thanks for attending. So, can I leave this event now?
Ah,
Yes,
yes,
ma'am.
ma'am. Yes. Thank you for
Okay,
the
thank you.
this
Bye.
fruitful session.
Yes, thank
So we can start the second half of this session at the 4, right?
Yes, teams, please join at 4 p.m. for the next session of the Ansys. Okay, thank you. Thank you for the joining.
Thank you.